Welcome to this video lesson, and this lesson is going to focus on the composition of unknown compounds. The first goal for this lesson is that you will be able to explain the law of definite proportions, and the second goal is that you'll be able to calculate the percentage composition of a compound. This is a picture of a robotic device called the Phoenix Mars Lander, and this was sent by NASA in 2008 to Mars. Its mission was pretty simple. Basically, it was to take samples of Martian soil and analyze it, and then by analyzing it, looking for organic compounds, so compounds that contain carbon in them, which would indicate that there was probably life on this planet at one time. Well, how does this robotic device work? Well, this device would pick up a sample of soil, and it has a furnace in it, so it would basically burn the sample, and the high temperatures would cause any water in the soil to vaporize, as well as any other organic compounds. Next, what it would do is use something called a mass spectrometer, and this is basically like a signature pattern, or what it shows is the molecular masses of whatever would be contained in this soil. Then using this quantitative analysis, scientists would be able to determine what organic compounds or what compounds would be in the soil. Well, bad news was it didn't actually find any organic compounds that would sustain life in the soil on Mars. But what it did find is one molecule. This molecule is called perchlorate, and if you remember from our Unit 1, it contains chlorine and oxygen. And what scientists have now found is that when this molecule is subjected to really high heat, it basically breaks down any organic compounds that would be in the soil. So basically what that means is that they're not exactly sure if maybe some organic compounds are on Mars. More research is needed. So here on Earth, scientists will use something called a combustion analysis apparatus to determine what the makeup is of organic compounds. Okay, so how does it work? Well, basically the sample that they're not sure what it's made up of. So they know there's carbon, hydrogen, and oxygen, but they don't know the proportions. They'll burn it to and allow for a lot of oxygen to allow for complete combustion. Then there are these two tubes. One collects the water, and the other collects the carbon dioxide. And from here, what they're able to do is determine the mass that's produced in each container. From there, they're able to usually predict or determine what the molar mass is of the compound, and then from there, they can figure out how much carbon, how much hydrogen, and how much oxygen it makes up this organic compound. Okay, so say scientists take a sample that's 2 grams. And they know that this is an organic compound, so it contains this carbon. They're going to burn it, they're going to put it through a combustion analysis apparatus, and what they find is that a 2-gram sample contains 40.0% carbon, 8.40% hydrogen, and 51.5% oxygen. Now what they're going to do is take another sample, and they're going to burn that one. But this sample is going to weigh 4 grams. Okay, and what they're going to find is the same percentage of oxygen, the same percentage of carbon, and the same percentage of hydrogen. So it doesn't matter how big the sample is, or small the sample is that's burned, the percentage of carbon, the percentage of hydrogen, the percentage of oxygen is always going to be the same for the same compound, which leads into the law of definite proportions. So the law of definite proportions states that the elements in a compound are always present in the same proportion by mass. And your textbook gives an example of water. If you have H2O, it doesn't matter whether you have a drop or a bathtub full of water. It's always going to be the same proportion by mass. Okay, okay, so let's do some calculations now. We're going to try practice question number 1 on page 286. If you can please turn there now. So this question is saying that researchers have isolated a compound that contains only nitrogen and oxygen. but they found that a 4.6 gram sample of this compound contains 1.40 grams of nitrogen, and they want to know the percentage composition of this compound. So they want to know how much is nitrogen and how much is oxygen. Okay, for this example, maybe think about when you get a test back, and say the test is out of 30, and you get 25. You're going to take what you got on the test and divide it by the total, and then multiply it by 100%. And that'll give you your percentage. Well, the same idea is used when we're calculating percent composition. Okay, so back to the question. We're going to follow the GRASS method. So in this particular question, they're giving us the mass of nitrogen, which is 1.40 grams, and the mass of the sample, which is 4.60 grams. What we're looking for here is the percentage composition of each element. So we're looking at the percentage of nitrogen and the percentage of oxygen. So our analysis, we're going to use an equation similar to what we would do to figure out our percentage on a test or a quiz. We're going to take the percentage for the element is going to equal the mass of the element that's involved, and you divide it by the mass of the sample, and then you multiply it by 100% to get the percentage. So let's try that for each of the elements involved in this compound. So the percentage of nitrogen is going to be 1.40 grams divided by 4.60 grams times 100%. So with the correct number of significant digits, we get 30.4%. Our grams units cancel out, and our final answer is in percentage. Now, to get the percentage of oxygen, there's a couple of ways you can do this. Okay, but if we know that the total mass is 4.60, we can subtract that 1.40 from that number, from the total, to get how much oxygen we have, and then we'll just apply this equation for oxygen to get the percentage. So we're going to have the mass of oxygen divided by the mass of the sample times 100. So first we're going to need to get the mass of oxygen. As we do more problems, usually if you're going to use this method to solve for the percentage of oxygen, you would just find the mass of oxygen right away and put it as one of your givens. But what we're going to do here is we're going to take our 4.60 grams, that's our total, and we just subtract it by 1.40 grams, that's our nitrogen, so that's our mass of the nitrogen, to give us the mass of the oxygen. So the mass of oxygen is 3.20 grams. Now that's the number we're going to plug into our percentage equation to get the percentage of oxygen. So our final answer is 69.6%. Now your percentage of oxygen and your percentage of nitrogen should add up to 100%. The last part of our GRASS method is the statement, so therefore the percentage composition of this compound is 30.4% nitrogen and 69.6% oxygen. Now what I would like you to do is look at sample problem number 2 on page 287 and then use that example to answer number 3A on page 287. So what you're going to do is find the percentage composition of sodium sulfate. Okay, so for this question, what we're going to do is calculate the percentage composition. So I hope that you've tried the question before you're looking at the solution here on the video lesson. So we're given Na2SO4, sodium sulfate. We want to know how much is sodium, how much is sulfur, and how much is oxygen as a percentage making up this compound. So the first thing we need to do is find the molecular weight of the sodium sulfate. You could find molar mass, but the units don't cancel out very nicely, so we usually solve this in terms of U, atomic mass units. So let's find the molecular weight for sodium sulfate. So you're going to look on the periodic table, find the molecular weight for sodium, multiply it by 2 since there's a subscript 2, find the molecular weight for sulfur, and then the molecular weight for oxygen and multiply it by 4 because there's a subscript 4, giving you a total of, so the molecular weight for sodium sulfate is 142.04 U's. Now on to our solution. We're going to have to find the percentage of each of these elements. So what you're going to do is find the mass of sodium that makes up this compound and divide it by the total. Find the mass of sulfur divided by the total, and then the mass of your oxygen divided by your total to get your percentage. Okay, so for sodium, there are 2 sodium atoms that make up this compound, so we're going to have to take the atomic mass of 1 sodium and multiply it by 2, giving us 45.98 U's, and divide it by 142.04 U's times 100%. Now, our atomic mass units are going to cancel out, and we're going to get left with the percentage. So in this case, our percentage is 32.37%. We're going to use that same rationale to solve for the percentage of sulfur, and then we'll do something a little different for oxygen. So we just have 1 sulfur in this formula, so our atomic weight is 32.06 U's. We divide it by 142.04 U's, which is the mass of the total sample, and multiply it by 100. Our U's cancel out and we get 22.57%. Now we're needing 4 significant digits here for all of these answers because we have 4 for this number, 5 for this, so we need to have the fewest number as your least precise original measurement. Okay, now for oxygen, we're going to do it a little different. We know that the total percentage is 100, so we're just going to subtract the percentage of your sodium and percentage of your sulfur to get your percentage of oxygen. So take the percentage of your sodium and subtract it from the percentage of your sulfur, and then subtract that from 100 to get the percentage of oxygen. So subtracting these values gives the percentage of oxygen of 45.06%. Okay, again, we need 4 significant digits. Our 100 is considered like a counted value. Okay, so we're going to use these 2 numbers to figure out our significant digits for our final answer. So this is one way you could have done it for oxygen. You could have used the same formula we did for sodium and sulfur. Either option is great. Okay, that's the end of our video lesson.